Hi guys, hope you are doing great and hope you are enjoying the content of generative AI class. So in this video, I'm specially making to answer few questions, messages, emails I'm receiving asking about the format of the midterm exam and the way it is going to be conducted. Okay, so mainly today this is what we are going to ask and discuss. And we are going to keep pending more content. So I'm not going to share more content because honestly speaking, I'm not seeing that much like progress, at least on lecture 7. So I wait for everyone to reach at that same level of auto encoders. At least then I'm going to post more contents about more complex, I would say, concepts like variational auto encoders and GANs and so on. Okay, so at least now until our midterm exam, things are simple and easy. And I would say this is your opportunity to get your full grade. Okay, so because it's possible. Now, what I would like to discuss is first of all is the format of the midterm. So it's going to be easy, like the homework one and quiz one, and it's going to contain a mixture of questions such as multiple choices. There will be short answers, there will be quiz, and there will be true and false. So it's like uh, easy, I would say. And even when there will be kind of long answers, I prefer that you don't answer long answers. So there will be some box and space for you given to write your answer. Try to make it short, okay? Because while going through the homeworks, I see like some answers in pages. I understand somehow it's AI generated, and I encourage using AI for sure. But I want that you used for learning, and sometimes even reading that much long like answers, I'm sure that maybe you didn't even have the time to go into all the details. So please make sure that it's a short answer. It's okay to get help from Google, from AI, from my recordings, from your notes or whatever, but at least make sure that you are brief, to the point, and I care about that human is understanding. So AI, no worries about AI. Now we humans must be understanding things, okay? Uh, so now I think I will need to close this parenthesis and mention that yeah, the midterm exam is going to be on Blackboard, and it will be kind of similar to quiz one in terms of like the way you are going to take, except that it's gonna uh, have more like types of questions, like I mentioned, and also it will be limited with time. So here, time is very important, and probably this could take us back to the long answers and so on. So time is very important. Try to make sure that you're answering briefly to the point and not wasting your time in one question, okay? Because if I know very well that you can use many resources, so probably my game will be about understanding who is really focused with the content, who is using the knowledge as a human that we like learn during this class. And I feel that from your submissions and so on. So in the exam, if you are like mainly watching all the videos, understanding what did we discuss so far, understanding kind of the content of the homeworks, you are good, okay? But if you are doing this, so if generative AI is doing this, I will be asking some tricky questions like I always did to distinguish if it's human or AI answers. It will be mainly one question, not more, don't worry. So, but try to do it yourself. So even you ask help, but you are the decision, like the one who takes the decision, okay? This is my point. So let's now share my screen. And let me go quickly through the homework and quiz. So mainly, most of you guys are getting almost or mainly full grade for that. Okay. So I take this. Oh, no worries. Okay, just I need to share my whole screen. Okay. So this is mainly for homework one. And so in the exam, it will be the same structure. There will be question about general understanding, of AI, machine learning, deep learning, okay? And here mainly we need to absorb and understand really well the difference between AI, ML, deep learning. This is like, for me, like ABC. So AI is mainly the broader field. And like you remember that picture, we have subsets and we have AI. Within AI, there is machine learning. Within machine learning, there is deep learning and so on. So mainly this is the answer, like AI is a broader field, ML is a subset, and it involves the algorithms that learn and like from data. Deep learning is a subset from machine learning, which mainly have the specification of it uses artificial neurons inspired by a human, the functioning of human brain, and it has many layers, and it's like the difference that it can deal with huge data sets and it can accomplish or work on complex tasks thanks to these too many layers. Okay, what is the difference between supervised and unsupervised learning? So supervised learning mainly involves training a model on labeled data. So the keyword is IC, labeled data uses different classes. So and the other one, unsupervised, we use unlabeled data, unsupervised data. We use it for different like purpose, such as like clustering and so on. It's my next question. The idea is to identify patterns or structures in data when it comes to unsupervised learning. Question 3 is about cross-validation. So it's a technique that mainly involving that you have the whole data set, you need just to split it into key folds, means like some kind of pieces, I would say, of data. And each time you are going to use different like fold for validation and the remaining for training. Okay, so here you are assessing the performance of your model. You're going to have many, I would say, performances. How you are going to proceed for the final one is by like performing the average across all folds. Okay, and next, what are some common metrics used to evaluate a model performance? So here we have the accuracy, the recall, precision, F1 score. There is a business metric also, and all this is discussed in the videos I was sharing with you. Okay, so next we have the classification and clustering, which comes based on the two different types of learning, supervised and unsupervised learning. Okay, so the difference between classification and clustering is that mainly classification is when we deal with supervised data, and we just explained what is supervised learning. And supervised data is when you have the annotation, the classes, that I would say the exact, if you have some data, you know what is that. So you have the label, the class, and that describes that a particular class, for example. So this is mainly for classification. It's supervised learning technique. And the idea is that the models, they predict labels for that data. Like we have KNN, you have the SVM, decision trees, and so on. These are examples. However, for clustering, it deals with unsupervised technique, like data. It's an kind of unsupervised technique that allows grouping different elements or data points together. And I was sharing with you the videos about k-means, how it works, and so on. And again, in like our new designed videos for the generative AI class, there is an explanation, abstract or like brief, I would say, explanation of the Gaussian mixture model, the GMM model. Okay, so now we focus on K-means and GMM, for which you have detailed videos about how they work and so on. So how K-means works, for me, this is fundamental and it's a must know. And when I say for me, it means like if you are going to keep working on the AI field, and probably you're going to go through some interviews. So even in the interviews, are the kind of questions that they can ask you, and this is the kind of knowledge that you must have. So K-means is unsupervised algorithm. It's used for clustering, and the idea is to assign each data point to one of K clusters that minimize the sum of square Euclidean distances between the points and their cluster centroid. Okay, and here it iterates for sure, like through two steps: the assignment E step and the update M step. So this we went in detail through in the video. But what I want to mention is that for k-means we do use the square Euclidean distance, okay? But again, in the video, a very important part was about the different types of existing distances. There is not only the Euclidean distance, okay? So like, even you probably will not watch my video, try to search somewhere else. What are these different types of distances? Okay, because they are very important, and the difference between them, because they are mainly the kind of basics that we use to measure the similarity between things, okay? And this is mainly discussed in the k-means part. So what is the difference between hard clustering and soft clustering, and how does GMM relate two of them? Okay, so we have two clustering types. We mentioned the hard clustering, and in hard clustering, kind of it's hard. So we are very strict about clustering. Very strict, which means that if you have a data point, so it belongs yes or no. Okay, there is 0 or 1. There is, like I always mention, black and white. There is no in between. There is no gray. There is no like that degrees of belonging. Also, if whether cold or hot, it's not warm somehow, or very hot or very cold, or the belonging with degrees like fuzzy logic. No. So the idea here is that the hard clustering assigns each data point to one cluster, like k-means. And for soft clustering, like the name mentioned, it's soft, which means that the assignment is not that much strict, which means also that if we are trying to assign, we will see that we have, for example, two classes or two main classes. So it can belong to both, but with some percentage, with some degree of belonging, we call it. Okay, so here it's soft clustering, and so it allows data points to belong to multiple clusters with certain probabilities. Like I would say today, it's mainly, it could be whether hot or cold if we are we are in the case of binary classification. Otherwise, today I was thinking it's cold, and then suddenly I'm feeling it's hot. So it's not really that like cold, and also it's not that hot. So it's, I would say, 60% cold, 40% hot. Okay, this we can see in that bell shape of the Gaussian mixtures that I was discussing in like the GMM lecture. Okay, so how it works, and like what is the difference between like the k-means example of hard clustering, GMM the example of soft clustering, now in terms of objective function and assignment method. This is very important. So k-means here minimizes the sum of squared Euclidean distance with the hard assignments. Okay, so we previously mentioned that whatever now the algorithm that we discuss, we have some problem, and mainly our problem is to optimize the error. So to optimize these errors, we usually use some functions. These functions mainly, they are optimization functions, and they compute the error, and we try to minimize this error. So for k-means, the like sum of square Euclidean distance is the measurement that we use. And this, for this one, so we assume that the spherical clusters are of equal probability, which means that all our elements, they have equal probability. For GMM, no, we do work on maximizing the log likelihood using the soft assignment, allowing a non-spherical clusters with varying probabilities. This is how we obtain the final result, where at some like examples of hard clustering, like k-means, we have strict results. For the GMM, we have probabilities of belonging, and this is how we introduce the concept of log likelihood during our class. Okay, so next we have the KNN and SVM. So mainly these are discriminative methods. I was keeping this like I think no, just give me a second. So general about area classification methods came in the GMM. Okay, this I will not, I would say, take from your time and go through this, but mainly this is what I usually discuss about discriminative methods, KNN and SVM. But for you guys, I just removed this, and I didn't mention the ensemblist methods as well, because I don't want you to get that much, I would say, information that is mainly not gonna help us later. So this is mainly I'm kind of skipping for our class. If you want to take screenshot and learn more about these, like discriminative methods, you can learn more about ensemblist methods. You are free to that, but I will not discuss this for now. What I will discuss is mainly the most important part, which is going to take us toward generative AI class, which is the neural networks. And so, first question, very trivial. What is the difference between an artificial neuron and perceptron in neural networks? Still, I'm asking this question, even that I was explaining 100 times, but it's very important. This is why I am insisting, okay? It's very normal to find this in the exam, so get ready, midterm, sorry. So, an artificial neuron is a basic computational unit inspired by biological neuron that takes inputs, applies a weight, sums a weight, then it sums them and passes the result through an activation function. Okay, that's all we were explaining mainly with this figure. If you want us to remember that we have something function like this, we have the inputs, the x and x1, x2, and so on. Then for each connection, like you have a weight, then you sum all the x's multiplied by their products. This is some function, and this is how you are obtaining your y. Okay, so Y is a multi-layer perceptron needed, okay? And how does it solve complex problem like XOR? So here I am making the question kind of simple, easy, but at the same time, so it's going to take you from a simple perceptron to multi-layer perceptron. So there is limitations of the simple perceptron, like it cannot work if we have I would say more complex tasks. It only probably works like for and for or problems. But if we have example like of nonlinear solution like XOR, we cannot use that. This is why we move on to work with the MLP. It's due to its multiple hidden layers, and these hidden layers, they contain kind of activation functions which introduce the nonlinearity to the like model, and this is how we learn like kind of non-linear decision boundary, which is required to solve this kind of problem. Because when you have this kind of problem, it's not like you have only linear like surface, that line that can separate both classes. You can have that kind of non-linear surface, okay, or curves. So how do neural networks work specifically if like in terms of forward propagation, cost function, backward propagation, and gradient descent? Okay, so in neural networks, you have the forward propagation. It means like passing the input through the different layers from input to the output layer, and then you will find kind of a cost function. This like measures the error between what is predicted and what is actual output. Then like what happens during the back propagation, we're going back from the last layer or output layer to the input layer again. The error that is computed is propagated backward to update the weights, and the gradient descent is used to minimize the cost function by adjusting the weights iteratively. Okay, so what distinguishes now convolutional neural networks or CNNs from other deep learning architecture, particularly neural networks? So here we focus on a specific type of neural networks, which is CNNs. And what we know about CNNs, that it's famous with its feature extraction block. So this is a key word in your answers. So feature extraction block is the block that comes beyond, I would say, the fully connected part. So we have many convolutional layers. We can have also max pooling and different types of layer, but basically we focus on the convolutional layers in our answers. So these are the elements that allow automatically learning specific hierarchies in data, such as images, which allows CNNs to focus on local patterns like edges and textures, unlike traditional neural networks that mainly do not have this feature extraction block and only focus or have the MLP part, or also known as fully connected layers. Okay. Next, now, why are convolutional neural networks often referred to as black boxes? So this is our last question. Here, CNNs are considered as black boxes mainly because they rely on random initialization of kernels and they learn features automatically during training. These learned features can be complex and difficult to interpret, making it hard to explain the specific decision-making process within the model. Okay, so I'm just reading my answer, and probably this reading, if you will listen to my video, I did this because you need, maybe even while cooking, while like you can just listen to this as a broadcast, because sometimes while hearing things you can learn as well. So there is a field that probably we can discuss later when we reach to the ethics in AI part. So I'm gonna teach this for the second semester. So for ethics and based in AI, this like kind of neural networks mainly have a superpower, and the problem is that they are not deterministic. And due to this random initialization of the weights, and so if you are running your model multiple times, you're going to have multiple results at the end. So there is not that deterministic final kind of accuracy or metric that we can rely on. This is why kind of sometimes explainability issues or trust in AI systems can arise, and this can even make us think of multiple, I would say, ethical concerns that I will be discussing next term if you're going to take my class for sure. So this is mainly for homework one, but before moving to quiz one, I would love to first say thank you very much to this student. I'm not going to share his name or details, but I'm sure if he's seeing this submission, he's going to know. So it's amazing and great job, and I appreciate the quality of answers because I understand that you're giving time to my class, you are learning, and this really makes me really feel so happy, not only. So what is special about the submission is that it mentions that for each lecture, he's putting the screenshots to explain examples of soft clustering, examples of answers for functions, how in here the MLP model works, or how even starting from the simple, I would say, model of artificial neuron and the connections between them, the different functions. Here the screenshot is again from the video about how neural networks works, the answers that I am explaining about the algorithm's 4 steps, the forward propagation and the computation of the error, the back propagation, and the gradient descent. Okay, so I love this. I really love this about CNNs, how it's he's using really the materials, because believe me, I am trying to make the content of this class very special, and I will probably again open a quick parenthesis, because this is kind of online asynchronous class, which is very challenging for the instructor. Okay, I'm going to express my feelings for now. So it's very challenging because even that I try to make the Discord channel, I want you guys engaged, but I don't see you active as compared to other groups of asynchronous class that I have. They keep sending messages, asking questions in their Discord channel. This is something I do encourage. So for you now, I will be taking some decisions to add some taste to your learning journey, but I will not bother you guys before you finish with your midterm first, okay? So this taste will be about the project that I'm going to share with the AI 502 session, and that is going to be like optional if you guys from AI 402 want to participate in order to learn. Okay, but it's optional for 402. It's mandatory for 502. Okay, I will discuss more about the project later because you have an exam and it's not the right time to discuss this. So now quickly I will go through quiz one. Most of you did great and had full grade for this one. So mainly this is about the introduction to generative AI part. Okay, so for this we have like the section one is about general question about basics of learning. So how like AI learns and or machines learns, I would say. So what is the main challenge of a computer starting from blank state in a chaotic real world environment? So mainly the problem is not related to lack of data. There is a lot of data around. The problem is not about the way to process or the efficient numbers and so on. It's not about supervised learning providing too much feedback. So we are not in that context. We are the context of real world environment. So here learning only from simple trial and error is extremely difficult and costly. So you remember the example of the picture of a baby Yahya driving a car. You're giving the car to a baby and you're asking to reach from point A to B. So imagine the mess and the accidents and the disasters. So this is extremely difficult and also extremely costly. This is mainly the right and correct answer. Okay. Next, why do humans learn more effectively than a computer using trial and error? So here the answer is easily that humans absorb knowledge from massive relationships, context, and observations. And this is the magic within our brains. So I don't know how it's made and how it works, but it's really like a superpower as compared to machines. So we do not only rely slowly on goals. Humans always start with supervised labels. No, I don't think that it exists inside. So humans ignore feedback from failure, and so mainly this is the correct answer is D. Okay, so next we move to supervised learning. In supervised learning, the computer learns by maximizing rewards in a game? No, because this is mainly about maximizing rewards and like in chess game and so on. We have some algorithms. No, this is not the case. Observing relationships and context. This is kind of tricky. I didn't want to mention this, but supervised learning is always when we have labels. It's not about the context. It's not about the relationships. Even that I discussed that too much in the class. And it's not about generating new content. This is generative AI, but supervised means we have labeled data, okay? And these labels are given by human experts and so on. Okay, so this is the C is the correct answer. For next question is supervised learning is limited because it cannot scale to label everything in the world. Oh, absolutely, that's correct. And so next we have which of the following is difficult to label in supervised learning? Texture data, we're already doing that. Image and animals, we're already doing that. Numbers and letter, we're already doing that. Love and friendship, this is very difficult to label in supervised learning and even in our real life. Okay, so this is the correct answer is C. Next, about like questions about reinforcement learning. Reinforcement learning relies on what kind of answer we have here? So observing relationships, no, it's not that. Labeled data set, no, it's not kind of supervised training at learning at all. Pre-trained models, we train them based on no, it's not the right answer. Trial and error guided by goals, rewards, and punishment. This is the exact example that I given like in the class lectures. A lot of examples about love, about like friendships, like for example, even about dealing with life. If you're the baby's touching something very hot, then first time you say, okay, let him touch, so he will learn, because he will learn from experience, and that experience will give him some penalty, and that is going to teach him to not do that next time. Okay, so we humans learn with like this kind of, we have the reinforcement learning concept, so it's inspired by humans. So it's mainly about you have some goals, some desires, some wishes, and you keep working on that. Sometimes you get reward, sometimes you get punishment. It's like life, it's ups and downs. So please be positive. I remind myself first. But so now question 7, reinforcement learning from scratch works well in chaotic real world environment. Oh, absolutely not. Okay, so if yes, then why we're taking generative AI class? Is not the case. And if yes, why we are moving forward? And if yes, then AI can do anything that human can do, because the chaos mainly is the difference, that we are able to manage all this chaos and live in this chaos, but machines are now struggling, they are learning. We are researchers working on like enhancing and working on giving lots of added values to this field. And the future is kind of scary if we do not consider ethics in AI. And otherwise that like kind of videos or like films about scary films, like the future, how robots are going to outperform humans, how they will rule the world, how AI will be kind of the decision even maker. So this can even happen, even not in our life and with next generation, if we do not keep the AI in its, we keep it some limits and some ethics and some responsible conduct. So problems can appear and happen. Okay, so we need to be very careful, because AI is amazing, it's interesting, but it will, and it can impact our future and the future generations. So this is why we need to be very careful. So why is reinforcement learning more successful in games like chess than in real world tasks? Okay, so chess has clear rules and limited options. This is why in the real world we do not have limited options. We have unlimited options. Okay, so I wake up and then I say, what will I do first? So it's kind of, can do anything. So, but in chess, it's kind of, we have that environment and it's clear. You cannot go out of the box. No, we can do whatever comes in our brain. And also like there are clear, sorry, rules in chess. In for humans, there is no rules, so it's very difficult to understand. No, it's like that. We are humans. We must enjoy that. I love that. So, foundation models and context. What allows foundation models to achieve powerful and general understanding? They learn from massive relationships and context across data. So this is the accurate and correct answer. Next, learning meaning from context and relationships allows AI to generalize like humans. Absolutely, yes. And next, which of the following is an example of a foundation model or for text? Del E, this is for images. GPT-4, yes, this is for text. Reinforcement learning agent, no. And chess AI, no. Okay, so the correct answer is B. Next, now we move on to questions about generative AI and AI concepts, which is the core of our class. So, generative AI differs from traditional AI models because simply it generates new content based on learned patterns. We started seeing this in the video for autoencoders. We will see more amazing things in variational autoencoders. And I wish that you guys stay engaged to this class. Because here probably I will move on to this video. Like for lecture 7, it's very strange that okay, I'm just here showing from YouTube, but I have the access to analytics, detailed analytics, and I wish I didn't have because sometimes having the information and the knowledge, it bothers. It bothers me when I see students who are not opening the content of my class from the day first they are registered. They are not checking any of the videos or any like of the recordings, any modules. They are not even opening. They are not doing the homeworks. It's crazy. But on YouTube here, it only shows you the views, which is very low for me as compared to what I usually get from in the first videos, because it shows if you are repeating that video again and again. So I understand. Like if I want to compare lecture 7 autoencoders 12 views to the introduction, maybe that everyone was interested. Maybe it's 53 views. So I feel that you lost probably the passion. I don't know. So please, if something is wrong in like the class, try to send messages. Be open. So I will be really happy to listen your feedback. Otherwise, this content I'm really making like with lots of love. Okay. So analytics, they are showing very bad, like for some students, I mean, but also it makes me too much happy to see the time that other students are spending, the assignments that they are opening, and they're checking the content most of the time. So these analytics are, after all, they're good. Okay, so I don't force you, I only encourage you because you are here to learn. So try to enjoy this learning journey. It's going to be quick and only maybe 6 weeks and it will be done. So try to learn as much as as possible as you can. Okay, so which of the following correctly describes the hierarchy of the concepts? Now AI, we have subset is machine learning, subset is neural network, subset is deep learning, subset transformers, foundation model, generative AI, and that is the correct answer. Next, now which statement correctly orders the hierarchy from general to specific? First, we have Gen AI is the most general, ChatGPT is the most specific. This is an application, okay? So between we find the GPT models, LLMs, and the GPT-4 in particular, which is like 7. The last question, like, is ChatGPT is the core model of GPT-4? No, so this is the false answer. Okay, it's not the core model. Okay, so this is only kind of the final app that we humans can access and use. Okay, so I mean, like any user can use. Okay. Okay, then finally, we are coming to the end of this video. What I wish is that I wish you good luck in your exam. And if you don't understand something, try to reach out. The video of autoencoders is included in the exam. There will be general questions about that. So make sure that you understand at least what are autoencoders. You understand the different like examples that I was discussing and the different types of autoencoders. Okay, so there will be questions about. Good luck. Thank you so much for watching.